Hello, fellow solvers. This is Cog with Cog Analytics, wishing you a happy new year. One of the things that I did to close out 2024 was participate in Advent of Code, which just celebrated its 10th anniversary. Advent of Code presents 25 days of coding challenges that will challenge your problem solving abilities. One of the things that makes this more enjoyable and a whole lot more fun, at least as far as I'm concerned, is that the Alteryx community will get together and try and solve these problems in Base A, or using nothing but Alteryx. A great group of people and a great way to grow your Alteryx skills. That's what we're doing today, and for the next several videos, ringing in the new year by reviewing how to solve these problems, hopefully as efficiently as possible, to learn and better understand the capabilities of Alteryx, learn how to frame problems, and hone our Alteryx skills so that we are prepared for whatever the new year throws our way. For that, let's dive into problem 1, or day 1, parts 1 and 2. One of the things with Advent of Code, day 1 is typically the easiest of the problems, or at least a very simple problem, and this trend continues here. So we can see we have in our input two lists of data of integers, and the first problem asks us to sort the numbers, pairing up smallest in the left list with the smallest in the right, then the second smallest with the second smallest, and continuing on until all numbers have been paired together from each list. Next, we want to figure out how far apart those two numbers are for each pair, and then we want to add up all of those distances to get our final answer. So simple enough. We'll go ahead and look at part 2 as well. We can see in part 2 we want to approach things a little bit differently. We want to figure out how often each number from the left list appears in the right list, and then calculate a similarity score by adding up each number in the left list, or the value from the left list, multiplied by the number of times it appears in the right list. Okay, so this is a little complex. We can check the sample case here just to make sure things make sense. So our first value is a 3, correct, and the number of times it appears in the right list is 3. Okay, so we can see once, twice, and 3 times it appears. That makes sense, but we see a redundancy here in the left list. How do we handle that? The fifth number 3 also appears in the list 3 times. So we do expect redundancy, and we want to add all of these together. Okay, excellent. And the similarity score will calculate and add it up. So let's jump into Alteryx then and code this up. So we have Advent of Code. This is all that we need for day 1 solution. Beginning with data prep, we have our input, which is 2 columns of data, but this comes as one field. Now we can see that it's delimited by some spaces. We can use the regex tool to parse through that, or in this case, tokenize, split that data into the 2 separate columns that we need. So we can see here we're setting 2, ignoring everything else, but what we're actually trying to parse through is a sequence of digits, a contiguous sequence of digits. And so we can see here that we have the 77442 is one of those, so that will be column 1 data. And then we have some spaces, which breaks and violates this rule. So the second column will have the next set of digits, which is 88154, and that trend continues all the way down. Excellent. Now we can use, since we're working with both lists independently, we can use 2 select tools to isolate the left list and the right list. Now looking at part 1, we want to sort both lists, so we can do that with 2 sort tools in ascending order, and we're going to join the data together in order to get that pairing that we're looking for. Now we're going to do this using a less common configuration of the join tool, which instead of joining by specific fields, we're going to join by record position. And what that does is joins record 1 from the left with record 1 from the right, record 2 to record 2, 3 to 3, so on and so forth, which is exactly the behavior that we were looking for. And so we can see one of the things actually to note is that when you do this, the output of the join tool will be the total number of records will correspond to the minimum records from both inputs. And so if there were an extra couple records in the right input, they would not be joined together to anything. Instead, they would come out of this right input. But we can see here, and we know from our input that the number of records in both lists is the same. So we have no issues there, and everything joins perfectly. We can throw down a formula tool and calculate the distance, which is the value from the right list minus the value from the left list, and the absolute value of that in order to get the distance between them. Make sure that you set your data type since the default is string because we want to be able to aggregate this as a number or as a numerical type. And that is exactly what we're going to do is we're going to sum all of those distances that we just calculated to get our final answer. Excellent. Looking at part 2, one of the first things we're going to do because we want to track how many times each value in the left list appears in the right, we will add a record ID. This is not technically necessary for this part of the problem because of the commutative principle in mathematics, but this is principally a very good thing to include. It's a good habit to build because we want to make sure that we are not losing any information at any point in time, especially for future problems in Advent of Code and just in general. We want to make sure that we are indexing and giving keys to each record so that we do not lose data in our workflows. So we add the record ID to the left list, and now we can join instead of by record position, we're going to join by the specific fields left list to right list because we want to see how many times, again, each value from the left appears in the right. And so we can see that when we do this join, our output is exactly what we would have expected. We can see record ID 879 appears a bunch of times because the right list has a number of copies of this value. And when we summarize down, we can see that better displayed here. So record 909, for example, with this left list value appeared 16 times in the right list. You can see that exactly here. We group by that, the record ID and left list values, and we're counting the right list. Now, one of the things that's important to recognize is that there are values in this right output here. So there are values in the right list that do not occur in the left list. Now, this does not matter for our problem, so we can ignore these, thankfully, because the number or the count from the left list will just be 0. And 0 times the value is just going to be 0, so it won't contribute to our final answer to the sum. But it is important to recognize that we have both data in both of these outputs and that we are consciously choosing not to use it instead of ignoring it, which can cause us problems later on down the line. And again, this is generally applicable in any workflow you build. You want to make sure that if there should not be data in these outputs, the LNR, that there is not data, that you are thoughtful of this. So we have that, we aggregate it together. Now we can calculate the similarity score by multiplying the value from the left list to the count, and we get for each record the similarity score. Again, we aggregate, summing all of those up, and that gives us our final answer. Again, very simple problem. For day 1, definitely a good kickoff, setting us up for the rest of the problems. They will get more challenging from here on out. Please like, subscribe, comment if you think you can solve this better, or if you had a different approach to solving it. I would love to hear it. As always, I hope this helps, and happy solving.